Hey, I'm Prashant, and like this is my first time with AlmaBetter, so like I'm hoping we can have a good session today. Okay, so the agenda for today's session is going to be Java, like the most basics of Java, especially the input and output is what we're going to be covering today, right? So we're going to start off by writing simple Java programs and like seeing how different how different inputs are taken, how different types of outputs are printed out, and a little bit about exceptions as well, right? So let's start. Is my screen visible, guys? I'm guessing. Let's see the chat messages. Darren, yeah, can we have introduction? Introduction. Okay, so your screen is visible, right? Okay. I like that. So we're gonna just start off by a simple Java program. Okay. So I'm assuming that all of you have had some, or at least a little bit of programming knowledge, like how you just start off writing code, right? And how you compile this program, how to make the machine understand what you write. So we're gonna go and try starting a simple Java program. Okay. So this is a file which has nothing in it. Just don't worry about this. This is something I wrote for myself. Okay, so what we're going to start is by clicking just a create file. You don't need this IDE. So I'm using Visual Studio Code. You don't need it, but you can do it on a notepad or anything that you want. Okay, so we're going to start off by creating the most basic template of a Java program. Okay, so we're going to start by writing public class my program. Okay, and in here, I need another method, public static void main. Don't worry about all these terms. We're going to cover it. I'm just going to write a few things. Okay. So this is the basic template. This is like the boilerplate code, which everyone needs to know. Okay. So this is a class and this is a function. That's it. And every class in the future is going to have functions. So if I create a new file, it's going to have a class, and inside that only I'm going to have more functions or more variables or whatever I want. Okay. Now let's say what I want to do right now is just do the most basic program for anyone, which is system.out.println, and I'm going to do hello world. So this is what is going to happen. Don't worry about what this X is. This is just my IDE doing this. This shouldn't appear in your code. It should just be system.out.println and hello world. Okay. So how does your computer understand what a Java code is? Right. I'm just going to keep switching between the chat now frequently. So if you have any questions, just post it in the chat. Okay. So this is what we have written. Now, how does a computer understand what I've written? So what I wrote here is something only you and I can understand. We can just see that, okay, this is a public class, and then, okay, the name of this class is my program, but this is not what your computer understands. Okay, so there is something called a compiler, which is going to convert all this into a different language, which we don't know what it is. Okay, it's going to convert your uh, programming language, and this can be anything. It can be Python, Java, C, whatever. This is converted into compiled code. Compiled code. Now this is going to be in a different language. It's probably assembly or RISC or something that you may not know, and you don't even need to know at this point. Okay, unless you want to understand how hardware and the proper cycle hardware part of computers work. You don't need to know that. And this is again converted into binary. What is binary? You just have like a series of ones and zeros and all that. And this is what your computer understands. Okay, so these are the different steps. So what we need to do is this code has to first be compiled. Okay. And once that's compiled, you're just going to execute it. And when that executes, it's all automatically going to convert it into binary. You don't need to know what's happening, and your computer understands what to do. So how do I do this? How do I go from here to here? For Java, it's pretty easy. So you just write Java C, and you need to type the name of the file that I just created. So in my case, it's myprogram.java, right? So I'm just going to put myprogram.java. Okay, so that's it. That's all I had to do to compile this file. Now, when I compile it, I can see this file. It says that you cannot display what it is. So I'm going to open it anyway. Let's see what it looks like. I mean, this makes absolutely no sense to me. Like, I don't know what this, like, I just know this hello world, and I don't understand anything else. This is something is written, but I just my this Visual Studio is not able to show what it is. Okay, but I don't need to know what that is. And next, I need to run this file. Okay, and when I run it, you just have to write Java and then the name of this file. So here in this case, it's just going to be my program. Okay, so if I run that, that's it. This is like the first line of code that anyone starts with. Okay, so this is the most basic of what a Java file does. So how you write a code, how you compile it, and how you execute it. Those are the three steps that you do. Now we can obviously compile a lot more files together, but you can only run one file at once. Okay, so you will maybe have 10 different files. You can do Java C myprogram.java, Java C myprogram2.java, and all that. But you're going to run just one file. And what is that file? The file that has this public static void main. Okay, so this is how you would execute a Java file, but I'm not going to keep typing this out so many times because I have this IDE and I can just hit this play button and it'll just do it for me. Okay, so this is doing the compiling for me, and this is executing also, and it just prints hello world for me straight out. All right, so since that's the basic, we're gonna start moving on to Zoom. Oh, you need it zoomed out. um I think I can close this and maybe this as well. Is this better, guys? Hope this is a little better. Can you explain the Java architecture so that we can understand it a bit better? So Java architecture, see, there's a lot of components involved, and I don't think it's a part of this uh, lecture because we have to cover just input, output, and exceptions. Right? Java architecture, you want to understand what is Java, like a Java virtual machine is a Java software development kit. So these are things you can search online. It's called SDK and JVM, and what was the other one? JRE, Java Runtime Environment. So these are different things which you are very high level things, and I don't think it's in the scope of this right now. uh, and yeah, these are again very hardware oriented stuff, so you might not need it right now. Okay, so Ishwar, I hope that's fine. Yeah, and I hope this much code is this amount of zoom is fine, because beyond this I think it'll be a little difficult for me to hold stuff. Okay, so now let's just go into this, and let's we've written the Java main function. All right, now I'm just going to go over what each of these things are. So we have public, which you can see in many places. It means that I can access this my program, or I can access this main anywhere in my directory. So say this is my project, right? This AlmaBetter project which I created. So this I can use, like I can have more folders, I can have more files, all that. Any file can access this because it has my program. Sorry, it has public. If it is private, it means I can only access it within this file. So maybe I'm writing something else over here. Okay, so I'm writing public, or I'm writing, let's say I'm writing private add two numbers. I need an int and add two numbers, something like this. Okay, so this basically means that I can only access this method within this file, or within this. There is another scoping thing, and that again is out of this topic. So these are called access modifiers. Okay, access modifiers. If you want to read a lot about it, so we have public, private, protected, and there was another thing. I'm not sure. I don't remember the name for it. Protected is the other one. Okay, these are called access modifiers, and yeah, these are just you don't need these in, like you can run a program perfectly fine without having any of these, but these are just good coding practices, right? I can write this code even like this, like I can just write, you know, where is it? Yeah, I can write this code like this, but it's not going to make sense to a user. Like, why am I writing everything in a single line? It's just a good practice to have, everything indented properly and everything written with proper naming conventions and all that. Like, I can call this whatever I want. I can just call it something like this, but you need good practices, and that's why these things are very useful. You don't want to make sure something random is able to modify your function or modify your code from somewhere else, and you don't know how it's happening. Okay, so that's why we have all these static. Okay, static again. I don't think it's a class for that because this again needs a different explanation of what are objects. So we're going to skip that. Void means I am going to return nothing. Okay, so if I'm saying add two numbers, okay, I'm creating int add two numbers, and I'm going to give int x, int y. I need this function to give me something, right? I need the sum of these two, and I can do x plus y. But what this x plus y is doing is it's just adding those two numbers. I'm not getting these two numbers. So to do that, I will write return. So that means I'm returning this function. If I ever call this function, it's going to give me an integer. Okay. So this main thing is giving me nothing. Okay. So basically, there's no need for a return statement here. If I was returning a string, okay, if I'm returning a string, then this should also be a string. So see, there's an error because it's returning an integer. So I have to give a string. That's what this is. So void means I'm not giving anything. So that's why I don't need to write anything. Now this main is the convention. You have to follow it because if you don't write main, your code will be like, where should I start? Right? I need the code needs to know, Java needs to know where is main. So that's why you have to specify this correctly. Now, string arguments. This is something which not a lot of schools teach, and you might wonder why that is. Because so when I wrote that terminal code, right, new terminal. So what is gonna happen is that this arguments. Okay, let's say I have a Java program. My Java program is not gonna hit this play button every time. Okay, this is hosted somewhere. This is somewhere online or in someone's computers. It's not gonna have this option of hitting play. It's going to what is it going to do? It's going to do that Java C myprogram.java and then Java my program. So that's going to run the code. Okay. So what if I want my program to get something? What if I want to give it some sort of an input, right? That input is given through this. Okay. So what I'm going to do is I'm going to give, I'm just going to print args0 and I'm going to print args2. Okay, so what that means is let me just first compile it. I have Java my program.java. Okay. Now when I'm running it, Java my program, I can give how many other arguments I want. I can give it like hello. I can give it like a number. I can give it some I don't know, anything I want. Okay. I can do something like this. I've given it 4 arguments. Okay. Now if I press enter, it's gonna. I don't think I compile. Sorry, I have to save this. Do it again. Yeah. Now if I print this, printing this first thing, which is hello, which is 0, and the second one, which is whatever word I wrote here. Okay, so this is how your code usually runs. It's not going to go and hit a play button. There's no play button when you're running code. It's always going to do something through command lines. So the reason to use this is, say I'm writing a Python code and I get something from that, and I want to use that result in a Java code. So that's what happens. So that result is what I'm going to put over here. It can be a string, it can be a number, whatever. But Java will understand it as a string, so everything goes in as strings. Okay, so this is what these arguments are for. These are called command line arguments, which is the name args. Okay, so that's what happens. This might be skipped a lot of the times, but it's important to know what these args are. And there's no length for this, so you can specify how many ever you want, and all of them will come here. Okay, so do we have any questions so far? Okay, wait. In Java, you don't need to call function. Let me. I didn't turn this in my. Okay. Oh no no no. We need to call a function with those parentheses, but this is not a function. This is not a function. This is a class. So you cannot call this. If you're calling something like main, which you shouldn't. Main should not. Main is very different. Like I wrote add two numbers, right? So that you can call. That you can just put the parentheses and you'll be able to call it. Okay. So now we have understood what these key terms are. Now there is, let's just go through a small portion of errors. Okay, now what are errors is just mistakes that you make. And mistakes can be of any type. I can make syntactical mistakes, like I can just make a spelling mistake here, and this might not even work. So let's just put a system dot out dot println. Okay, so let's just try running this. And Java C and Java. I don't need all these arguments anymore. Yeah, exception and thread main. So it was just trying to find a main function, but it wasn't there. So that's why we got this error. Now there are different types of errors that you can get. One is syntactical, which is I'm making some typo. So if I write a word like this, it's going to be another error. Then there can be some runtime errors, which is I want to do 1 divided by 0. What is this going to give me? This is also going to throw an error, right? 1 divided by 0 is not possible. So it says, am I not compiling this? Sorry. Arithmetic exception, divide by 0. So that means it's not possible to do something like that. So these are all different types of errors. If you're writing all of this in a notepad, you'll not see the errors, but because this is an IDE, I'll be able to see if I make any mistakes. Like if I have something like this, it'll tell me the method print qln is undefined. That means there's nothing like this. So I'll know how it is. But if you're writing it in a notepad or somewhere where there's no access to things, then this might not be there. And you'll only get to know about your errors when you compile or run stuff. Okay, so let's clear out the whole thing. Right. So now let's talk about how to take inputs and how to take outputs, right? So we have definitions of basic keywords, syntax errors is what we did, logical errors also what we did, data types and integer. Okay, so this data types is something that is there for every programming language. Okay, you will either be storing some strings, or you'll be storing numbers, or you'll be storing characters, something like that. Okay, now to store this, you need a data type, and Java has a few data types. One is int, which is you can store any number that you want. One is char, which can store a single character. Okay, let's store f. Now, if I'm uh, adding another character like say fa, it's not going to happen because character is just going to store one single letter. Okay, and this can be anything. This can even be a number. This can be one of the special characters. This can be literally anything that you want. Okay, but just a single character. Then we have float, which is decimal points. Okay, so if I can do something like this. Okay. Float is, and I think float f is equal to this. What's the error here? Cannot convert from double to float. Okay. Let's again, I don't think I'll cover this. Okay, float is one thing. Don't worry about why this f is there. It's just telling that it's supposed to be a float. Okay, next let's also talk about long. L, there is double T. And we have Boolean. So these are the main data types. Okay, so int and long are the same. Int is, of course, there's a limit on how big of a number you can store. Okay, it has maybe 10 power 9, I think 1 billion, approximately 1 billion or 2 billion is the limit. If you want it beyond that, then you'll have to use long. Okay, and long is almost like 2 billion or like 4 billion billion. So that's a very large number. Same with float. Float also can store only some limit of numbers. Double can store double the amount of that, almost up to 10 power 300. Okay, so that's a very huge number. And usually when you're declaring a float, you have to put this f. So don't worry about this. If you want to use a decimal point, just use double. It's fine. Okay, just use this double. Character, as I said, it's just for a single character. And Boolean is a true or false statement. It's just these two values. It'll either be true or it'll be false. That's it. Okay. So for now, I think these data types are more than enough. But for today's topic, we'll just be talking about int. Okay. So let's go step by step of what we'll do in int. So we have different operations, right? The plus, minus, divided by, multiply, and modulo. So let's do steps one after the other. We'll have two integers. Int a is equal to 16, and we'll have int b is equal to Let's say 9. Okay. So operations, how would I want? So int result, I'm going to do, or I'll call it add. If I add these two numbers, what am I going to get? A plus B. Okay. So this is going to do 16 plus 9. So that will be 25. If I do int subtraction, I'm going to do A minus B. And that is going to give me 16 minus 9, which is 7, right? Let's print these also. System dot out dot println. Let's do println. Let's do add and sub. Let's see. Yeah, we have 25 and we have 7. Okay, so those are our two things correctly. Now let's do int multiplication. A into B and int division, which is equal to A by B. So let's just comment these two. We have multiplication and we have division. Okay, so before we do this, can someone, like, what do we expect over here? So here we are expecting something of A into B, which is 16 times 9, which is what, 144, I think? Or how much is it? Yeah, it should be 144. And 16 divided by 9 is supposed to be like around 1.7, something like that. 7, whatever. Okay, but we are not. Okay, wait, let me go through this. We are simply printing hello world, then args is needed. No, you don't need args. I'm going to go through these questions once. Okay, then args is needed. No, args is generally not needed unless you are, you want something as an input which you don't know. Okay, so you won't need all of these in args in general, at least in the beginning stages. So explain syntax in more detail. Rishabh, can you like explain what syntax was missed out? Because I wanna go. I can go through it. Yes. Okay, simply yes. That's a common parameter for the main function. Wait. Oh, no. Yeah, you need to have args. So yeah, sorry. What in case you're asking if this syntax is needed? Yes, you'll always need args irrespective of what you do. Okay, you cannot just write a code like this. A main function always needs arguments. Okay, that's this part is needed. Okay, but do you need to use args? No, you don't need to use args. So explain syntax in more detail. Yes, does the store default value when we just define then and not assign them values later? Yes, you can do that. So when you create an int, something like, if this is what you're asking, if I do int x, at least C, it will by default assume that this is this is 0, but Java does not understand that. So if I'm going to do system.out.println for x, it'll say x is not defined. Right? What is the error here? The local variable might not have been initialized. So Java does not let that. So Java always ensures that you declare or you give it some value. Okay, so that's why you need to write that piece of code. Okay. So we have that. The default values, no, these two. Yeah. Okay, so these values are, you'll have to add. So even over here, when I'm creating add, I cannot just write add but I can do it later. I can do something like int a or int g, and like I can write the code however I want. And maybe here I want to do something like g is equal to a plus b minus 4. That is possible. Now I can use g however I want. Okay, so I just have to make sure that before I use it, and by use I mean like you're using it either on like something on the right hand side of the code. Okay, so system, you're like printing it, or you're using it another operation. You want to create int a is equal to g plus 5. Okay, that's where you're using this value, right? You have to make sure that this value is initialized before that happens. So this can happen anywhere in the code, but if you're doing it without initializing, you'll automatically get an error. Okay, so yeah, if I did system, okay, I'm going to int h is equal to g plus 1. This is going to throw an error saying g may not be initialized. So if I write the same line here, I won't get that error. Here it's saying h is not used, but yeah, g now has a value, so I'm allowed to use it however I want. Okay. So yeah, anyway, let's get back to this. Multiplication is a into b, but division is 1.7. Let's run this code and see. Save this. Yep. So it's giving me 144, which is what I expected, and it's giving me 1. What is 1? It's just giving me this. It's not giving me the decimal, like the floating value of this. Okay. That is because this, in all programming languages, this is integer division. It means that if I'm dividing a by b, I'm only going to get the integer value of it. Okay, this is similar to when you're doing a division of 25 divided by 7, you'll get quotient as 3 and remainder as some zero point 0.5 or something, right? So that quotient remainder concept is what is going to come into picture. So if you do a by b, you're going to get your quotient. And if you do a modulo b, you are going to get your remainder. So let me just write the remainder here. Int rem is equal to a modulo b. Okay, if I print this now, so now I'll get 144, 1, and then the remainder when I divide a by b, I'll get what? 16 divided by 9, the modulo is 7, correct? So let me run this. Yep, so 144, which is the product, this is the division, and this is the remainder. Okay, so that's these are the basic operations of basic arithmetic operations that you'll find. Now, to understand this better, let's see how I can chain these. I can write this however I want by adding more stuff. So let me comment these out and give another example of what we're doing. So I'm going to write int value is equal to, I'm going to give us a small equation. You guys can try this out. Plus 2 6 by 3 into 5. Okay. Just try this out. I'm going to give you guys a minute. I'll just get some water. All right. Just try that out for a second. And let me know what the answer is. So has anyone been able to try it? 14. Okay. Can we do system.out.println a by b? Yes, you can do that. Okay. So we have one answer, which is 14. So let's see how that is. Normally, if you're going left to right, it's going to give me 4 plus 6, which is 10. 10 divided by 3. What's the quotient? It'll be 3, and 3 into 5 is 15. But in normal mathematics also, we know that we don't do this. We have to do these divisions and multiplications first, right? So which of these is going to happen? Like, is it going to be 6 into 3, or is it going to be 3 into 5 first? So in programming, your division, multiplication, and remainder, which is the modulo thing, happen first. They happen first. And how do they happen? They'll happen from left to right. Okay, so they happen left to right. And after that, your addition and subtraction will happen. How will they happen? Left to right again. Okay, so what is happening here? We'll first do all the divisions and multiplications. So I'm going to do 6 divided by 3 first, which is 2. And then 2 into 5, which is 10. So no more divisions, multiplications, and everything's done. So now this is 10, and now I'm going to do additions left to right. So 4 plus 10 is going to be 14. Okay, so that's what we're going to get here. This is out. This doesn't work. Println. Uh, Someone had asked if we can do A by B, right? Like I'm going to print this now instead of printing value. Let's see what happens. Right, so we have 14, which is pretty straightforward. So if I did something like this, now what would the answer be? I'm gonna like let's just go through this anyway. So we'll do all division, multiplication, and remainder. Like this order really doesn't matter. I can do remainder first, multiplication first, division first. But how would I do it? I'll go from left to right. So left to right, let's go. First, I'm doing 4 modulo 6, which is going to give me 4. Okay, if I divide 4 divided by 6, I'm going to get quotient as 0 and the remainder as 4. So this is 4. 4 divided by 3, which is 1. 1 into 5 is 5. Okay, so the answer should be 5. Let's hope it is. Yep, it is 5. Okay, so these values are always going to be left to right. If you want to change it in between, then the best way to do it is by putting brackets. So if I do this first, okay, so what's going to happen is 6 divided by 3 will happen first, so that's going to give me 2. And when I do 4 modulo 2, I'll get 0, right? Yeah, 4 goes perfectly in with 2. So 4 modulo 2 is going to give me 0, and 0 into 5 is, we get 0. Okay, so this is the two rules that you'll have to know. These happen from left to right first, and after that, addition and subtraction happen left to right. Unless you have brackets, it means you will do that first. Okay, so that is like the basic rule. The rest is the same pretty much everywhere. Now there are a few more operations like bitwise operators like uh, XOR. I can do AND, I can do OR, I can do NOT. These are bitwise operators, and these also have their own precedence. So I can do something like AND, I can do an XOR here, but these are, again, you'll need to know bitwise operators to understand what they are. So maybe you can use that as a homework or something, or maybe however you want to learn. Okay, so this is going to give you probably a very unexpected output. It's okay, going to give 5 anyway. Let's do this. This might give an unexpected output. -6. Okay, anyway, it's fine. So you can go through bitwise operators. Okay, so these are the 4 bitwise operators: XOR, AND, OR, and NOT. So maybe go through this and see how they work. Okay, so now we've gone through basic 5 basic operations and the precedence. Precedence is this order that we have. Okay, so now let's go through what do we have next. We have all these. Yeah, so here let's just look at this. We have 3 into 5 minus 2. So 15 minus 2 is 13. 3 plus 5 by 2. 5 by 2 is going to give me 2. And 3 plus 2 is 5. 3 minus 5 minus 2, it happens from left to right. So it will be minus 2 minus 2 minus 4. And yeah, I think this is very straightforward. Okay. Yeah. Next, we're going to see how to do outputs in Java. I mean, yeah, we've already done the system.out.println like so many times, right? Like I've done this already like 10 times already, like multiple times. I've just been doing this. So this is a class. Okay. This is somewhere there in Java, just like how this public class my program is. There is a public class system. Okay. You don't need to know how it is implemented, but it's there. So this is, the system class contains several useful class fields. It cannot be instantiated. And yeah, I mean, you can read the documentation. Out is like, again, you don't have to worry what out is. It's another static field. But println is a function, just like this. And what does it need? Here you need some string arguments. Here you can put literally anything you want. Okay, you can put an object, you can put an array, you can put numbers, you can put variables, whatever, and Java will understand what you're trying to print. Okay, so let's just comment these and start fresh on this page. So let's do system.out.println. We had started with hello world, right? So now what this println does is it'll print whatever is there here and it'll print a new line at the end. Okay. So I'm going to do two things. I'm going to do system.out.print and I'll give you hello world. Okay. So let's see how it's going to print it. Did it not work? System.out.print. Let me clear this. Okay. So we're going to run this. Yeah. So I've printed this hello world and you see this thing, this my name, like the thing, it's happening on the same line, right? If I just put print ln over here and run the same code, it's going to print hello world and then it's going to print a new line, right? It's going to do that. When you press enter, it goes into a new line. That's what ln is doing. Okay. If you don't put this, it'll just print it in the same line. So if I want to do uh, print hello and then I want to do print world, right? That's what I can do. So I can print hello and then I can print world here. So this is going to print me hello world in two separate lines. Hello world in the same line, sorry. So if I do print ln for both of them, then it's going to print hello in the first line and then it'll print world in the next line. Okay. So that's a main difference. Print is going to just print whatever it is. Print ln is going to print with a new line. Okay. If you want to print a new line while using this, you can just write /n. Okay, this is another way of writing println. So what println does is this only. It'll just do system.out.print and it'll put a /n at the end. But because there's a function for doing this new line, it's already there. You don't have to explicitly write it in println. These are called escape sequences. Like there are different things. Again, there's going to be /0. There's going to be /n. There's going to be /b. The /n is a new line, and that's all you need to know for now. Okay, /n is going to be a new line. And okay, this is a question I get often. What if I want to print this? What if I want to print? What if I actually want to print /n? That is a question I get often. So what happens is I cannot just do this. I cannot print /n because what it's doing is it just print a new line. It's not going to print that /n. So for that, I first need to print a slash, and that is done with this. Okay, so this is going to print this slash as it is, and then it's going to print n normally. Again, this might be a little confusing, but this is how it is usually done. Wait, where is? I don't know why it's not working. But yeah, I don't think, again, you don't need to know all of this. So here you have /n printed as it is. So just like how I mentioned, /0 is an escape sequence, /n is there, /b is there, just like that, slash is also there. Okay, so we have system.out.print and system.out.println. Now is the new thing, system.out.printf. Okay, so what is printf? Yeah, I think in C or C++, you would have come across printf statements, right? So this is just the same thing. We have to write it also in the same thing, like how you write in C. Now, what is the use of something like this? Let's say I have int a is equal to 5, b is equal to 6, and c is equal to 7. I want to write something like the sum of a, b, and c is, what is it, 18. Okay, so this is out.println. I'm going to do the sum of a. A as in I want to print 5. Okay, how would I do that? I can just come out of the string and print a, and then I can do an a plus e plus there's a space plus c, there's a space. So what is happening? The sum of this is going to give me the value of a, which is 5. This is going to print the value of b, which is 6. This is going to give the value of c, which is 7. So it'll print it as it is. The sum of 5, 6, 7. I can just go here and write is, and then I can put a plus b plus c. A plus b plus c. Okay, now if I print this, it's gonna say syntax error needed semicolon. Okay, the sum of 5, 6, 7 is 18. Okay, I got that. Now, what if I want to put some commas in between? I want to, the sum of 5, comma 6, comma 7 is 18. Now I have to find in this entire function, like where is that a? Okay, it's here. Okay, a, comma b is here, comma c is here. Now I'll print it. Now this is going to get very confusing because if there are more terms I want to add, I have to put so many pluses, so many colons, so many quotes. It's going to get very confusing, right? So that's why we have something called a formatter. So what that does is, I'll just write it as printf, and I can just put the sum of percent %d, and percent %d means a number. Okay, it can be any number. %d, %d, and %d is, what this is telling me is that the sum of a number, and a number is a number. Now you need to specify what are these numbers. So the first number is going to be a, second number is going to be b, third is going to be c, and the fourth is going to be a plus b plus c. Okay, that's it. Now this is so much more easier than what we just did, correct? And of course, if you want a new line, you put a new line here. Okay, so now this is a lot easier and a lot nicer to just read and understand. So the sum of a number, and number is this. And I can swap these values around. I can just put b here, and I can put a here. And this will still work. It'll just be that this first number is going to be replaced by this is going to be replaced by this, and so on. Okay, %d is for numbers, %f is for floating point, and %c is for characters. And yeah, you don't need to know any more than that. So this is a formatter, and there's system.out.printf, and there's also system.out.format. Both are the same. It's exactly the same. You can write whatever you want, whatever is convenient for you. Okay. There was another thing which I wanted to mention in the previous thing itself. So let's say I was writing system.out.println. I was writing the sum of A and B is, and I'm going to put A plus B. Let's see what's going to happen here. I'm going to comment this. So the sum of, okay, this needs to be that the sum of A and B is A plus B. Let's run this and see what we're going to get. The sum of 5 and 6 is, it's saying 56. Okay, this is not true. Of course, like 5 plus 6 is 11, correct? So what is happening here is when Java saw that, okay, you are creating a string, it'll just think that, okay, everything is a part of a string. So I'm going to put the sum of 5 and 6 is 5, 6. That's what happened. Okay, so this is not correct. So once it starts thinking it's a string, everything after it, it'll just assume it's a string only, and it'll keep doing it. So if you want this to be an actual number, you have to make that operation happen. So that's why I put these brackets. When I did the sum of A, B, and C is A plus B plus C, I had to put these brackets because now what's going to happen? The brackets occurs first, right? So the brackets always happen first, like just now when we were doing those math operations. So this happens first, so we get 11 over here. And when we execute the rest of it, we're going to get the sum of 5 and 6 is 11. Okay, so this is something to keep in mind. And of course, this is obviously much easier when you're doing the system.out format, because here I didn't have to put brackets at all. Okay, because here it automatically understands that this is a number. So it's going to convert this into a number itself. Okay, so that's why it's better. Like, it'll depend on your use case. If you want to print a lot of variables, then you'll use something like a format or a printf. But if you need to print just a string or just numbers, then you can use println. All right. So do we have, yes, it's a concatenation. Do we have any doubts so far? Java is interpreted or compiled. Java is compiled. That's what we did. When we did Java C, it was compiling a thing. So it'll compile the entire code at once, and only then after which you can run. Okay. Any other doubts, guys? Now that we've covered outputs, we'll cover inputs for a bit. Okay. Any questions? What's the time? Okay. Okay. No questions. All right. Let's go into inputs next. So for inputs, you need to know a small syntax. So we're going to use something called a scanner. Okay. A scanner. And this is how you create objects in Java. This is system.in, and I think we need scanner from a class, right? Okay. Okay. So now what this line does is I'm creating a scanner. A scanner is an object that is going to scan something from here. Okay. So whatever I type here, let's clear this for a bit. Okay. Whatever I type here, Java is going to take it as an input, and whatever you want to do with it, you can do it. Okay. So that is what a scanner is doing. Now, what is this syntax? Like, this is like one heavy syntax that appeared out of nowhere. This is the name of the scanner that I'm creating. Okay, so this is just like int x equal to something. All right, just I'm creating a int x, meaning I'm creating an integer. Scanner meaning I'm creating a scanner object. Okay, and when you're doing int x equal to 15, you know what 15 is, but here it doesn't know what that scanner is. So you have to create this scanner object, and where are you taking the input from? So this is system.in. You know how system.out.print is printing everything here? So similarly, system.in is coming from here. Now you might ask me, what are the other places like I can write? Isn't this like system.out and system.in the only things? Why do I even need to mention? I can read from files. So when I'm reading from a file, I can just put the path of it, like Windows, desktop, AlmaBetter slash Prashant slash file name. Okay, that kind of thing I can mention here. Or if I'm reading from a different socket or something else, I'm going to mention where I'm reading from. So this entire console is a system console. So we're going to be system.in. That means everything that is coming as an input will be scanned. And if I'm printing it, then I'm going to do system.out. So I'm going to print everything here. So you can also print to different files. So there are different classes for writing into files and all that. But yeah, system.in is just scanning from here. So this is your syntax for creating an object. And a scanner does not exist by default. You have to bring it in. Okay, you want to tell your code that, hey, I'm going to use a scanner and I need it from somewhere. And this is what it's doing. Import from java.util.scanner. I'm getting that scanner. Now I can use it however I want in this file. Okay. Now using this is very easy. So if I want to scan an integer, I'll do scan dot, I'll just do next int. That's it. And I can scan an input from here. So I'm gonna do system dot out dot println, and I'm gonna print x plus 10. Okay, so if I run this, let's go. So now it's waiting for my input, and if I give it the number 7, it's gonna print 17. Okay, so this is gonna take an integer input. Now, if I want a string input, there are two things which I can do. Let me comment this. Entering string s is equal to scan dot next. Okay, and or I can do scan dot next line. There are two things. So I hope like we've done println, right? So println, what does it do? It'll print everything and add an enter at the end, right? It's going into that new line. So scan dot next line is the same thing. It's going to take input until you press that enter button. Okay, so let's run this, and actually let's print also system dot out dot println s. Okay, so now I'm going to enter something like hello world, this is my first program, and it printed exactly what it asked for. Okay, so scan.next line is going to take the input until you press that enter button. Okay, so I'll write comments also for this. Takes integer input and takes input until you press enter. Okay. Now there is one more thing, which is string scan dot next. Now this is slightly different, and this might be useful in some cases. What this is going to do, let's see. So I'm going to run the program, and I'm going to type the same thing. Hello world, this is my first program. Now if I print it, okay, I think I took another input. Yes, scan dot next line. Oh, okay. I have to write again. Hello world, this is my, okay. So now when I print this, it's just going to print this hello. It's just printing this one thing. You can see that. So what scan.next does is it takes input until a space. Okay, so this one takes input until you press that enter key. This one takes input until there is a space. Okay, so that's the only difference. So if you want to keep on taking inputs, you're going to do something like a while loop or a loop where you're just getting so many inputs. Okay, so let's write a small code to see what's happening. Let's say I'm going to enter 5 words. Okay, so int words equal to 5, while words. Don't worry about what I'm writing here. It's a loop. It's just going to run this code 5 times. Okay, I'm just going to take this and print it here. Now what is going to happen? I'll run this, and it's going to take 5 different inputs. So I'm going to write hello world 1, 2, 3. So now it took 5 different spaces. Also, yeah, takes input until a space or enter. You can take enter also at the end. So that's what happens. So I first took hello, then world, then 1, 2, and 3. So hello world 1, 2, 3. All right. Is this clear? Is this part understood? How system.in is working? How we take inputs? Line number 12. What's line number 12? What happened here? Anmol, you could maybe describe a little more. Okay. So we have all the inputs taken. Let's say I think we've covered most of what we needed for today. I think there's one more small topic of exceptions, and I think after that, which we're done. So we have Java package, get into your scanner, it's done. Oh yeah, let's do this input.close also. Yeah. So yeah, another good practice to do is after you are done using a scanner, you close that scanner. Okay, scan.close. It's not going to do anything in your program like the output part, but again, as I said, it's a good practice to follow some conventions. So if you're opening a scanner, you're starting a new one, then it's good to say that, okay, I'm done with this, and then you just do scan.close. Okay. Are there any more doubts? 14 now. Okay. 14. Yes. What exactly do you want me to cover in this? Like I want to know like where is okay. Yeah, public static appointment. Is there anything in particular that you need me to explain? Are there in classes struggling with this? Oh, okay. So this is a line that is basically telling your Java program where to start from. Okay, so when you start running a code, okay, when you run a code, when I'm like pressing this play button, it's going to go through this entire program and start searching for that one place where this public static void main is. Okay, public means that okay, I'm going to press that play. So if it was private, it is not allowed to access it from anywhere. Okay, public is going to make sure that I can access this from anywhere in this project. Okay, so when I hit play, it's first going to look for all the public methods. Static, don't worry why you need static. It's has something to do with objects and all that. How would you uh, create an object? But don't worry about that. Void means I'm not returning anything. it means that after this main function is done, like I'm not getting anything out of it. Okay, so I'm going to run this program, it'll do whatever it wants, and that's it. I'm not going to expect anything from main. It's not going to give me a number, or it's not going to give me like a status saying, okay, you have done this correctly. No, nothing of that sort. It's just going to run everything as it is. That's what void means. Main is the name. So if you make a small typo in this, your code will not run. This is standard. And this arguments is something that you pass into your function if you ever need. So if I'm pressing play and I want to press play with some extra things, say I want to press play and also automatically give it some numbers or some values or some strings. Okay, that's how I'll pass this string arguments. Okay, so these are called command line arguments. It's something like this. Okay, so this is your compiling, and this is your executing, and this is telling me what I should execute. So my program, that is this. And when I do my program, it's going to search within this, where is that public method, where is that public method named main, and am I going to expect anything from it? No, because it's void. And string is if I'm passing anything extra. So after my program, I haven't passed anything, right? I haven't said anything here. So if you want something extra, then this is where you put it, and in your code, it'll appear here. Okay. So yeah, okay. Now the last comparison, Java is faster or JavaScript. Hmm. So JavaScript, I mean, you can't compare those two things, right? So Java is something where you just build applications on your desktop. I mean, if you had to, you can do different things and make one faster than the other. Like, say, if I'm not doing system.out, I'm doing something else. So scanner is super slow. Okay, I mean, of course, this is very fast, but when you're trying to do hundreds and hundreds of numbers, scanner is like the slowest thing ever. So there are much better ways to take inputs. System.out also is like super slow. You don't want to do that, but again, there are much faster ways of doing it. So it depends on the things, but you can't compare which is faster, and like everything has its own applications, right? You cannot. You can compare something like C and Java because both have very similar applications, but JavaScript is very much into web development, right? Java is more into application development. So you cannot compare those two things. But I mean, if I had to say, like JavaScript is like very versatile, and yeah, exactly, yeah. Thanks, Vinay. That's what I wanted to say. Like JS has Node and Java has Spring for backend, which is good. Again, it depends on what you want to use, right? You cannot just, it's like comparing, what's that saying? It's like comparing apples and oranges. Yeah. Okay, so let's take the last concept of today, which is exceptions. Now, when you're writing a code, like I will not know if there is, um, what is a good example I can think of? So when I'm writing a code, I want to make sure that the input that I get is perfectly correct, right? So let's say I'm expecting an email address from you, okay, and then you don't put the symbol at the rate, right? So let's just comment these out for, we don't need them anymore. Okay. So let's say I'm expecting an like what is it? It's an email input, and I'm going to write in my code, is this a correct email? Now I'm going to write this uh, thing like, okay, is there an at the rate symbol? Does it end with .co.in or .com, or all these things? Now I cannot keep writing if else, if else, if else. I can't keep checking every single thing, right? It's gonna take forever. So that's why in programming there are going to be, when you're writing proper applications, there are going to be situations where you will not know what is going to happen, like what is there something that we will not even witness, but somehow it just happens, right? So for that kind of things, you want to make sure that your code doesn't just stop or break, right? So I'm going to write okay, I'll just create an array. Don't worry about how these arrays are created. Like I'm creating an array of 5 numbers. Okay. And I start writing a loop for int I equal to 0, I less than 10, I plus plus. Again, if you guys don't know about for loops, then it's fine. I'm just saying that I have an array of 5 numbers, and I'm trying to print the first 10 numbers of this array. println, and I'm going to do a of I. Okay. Also, someone had asked me if I can do something without initializing. Arrays you can, because arrays, when you create an array, it will create 5 zeros in this. Okay, so when we did int x, we needed to initialize this to some number, right? For arrays, that's not needed because by default, an array creation will create 5 zeros. Okay, so let's run this. Yep. So it printed 0, 0, 0, 0, 0, and then it just printed, oh, we are trying to access a number which is not there, right? So I have only 5 numbers, but I'm trying to access the 10 different numbers. And this is a very small thing. I know it's a very stupid thing because I know it clearly says 5 numbers, and why am I trying to access 10? But in the real world, that situation might not happen. You might have something which is totally unexpected, right? So those kinds of things. And if something happens like this, okay, yeah, let's actually do this. System dot not out dot println end of program. Okay, so now what's going to happen? Let's see. So if I run this, it prints at 0, 0, 0, and it just stops over here. It's not even going to this part of the code. It just crashed the whole thing. And if something like this happens where you're crashing a system, then that's going to be a problem, right? Like you cannot just end an application out of nowhere. So that's why you have exceptions. So you're going to handle such errors without making your entire program fail. Okay, so that's what you are going to learn now. And how do you write code in with handling exceptions? Is you're going to put a try, and here you're going to write whatever you want, like all the code that you've written today, right? We're going to put all of that inside try. And if ever there is an exception, so here I'm going to put uh, any code you want to run. Now, if there's anything that breaks this, you'll go into this catch. Okay, so there is some error that was thrown. So, for example, what was this error? Array index out of bounds exception. So, if that happens, or if anything happens, I can just write exception p. So, in this case, I can just do system.out.println, and then I can say print p. What is going to happen in this same code is that instead of stopping this code as it is, right, instead of just stopping it, it is going to gracefully say that, hey, you have an exception, and I'm going to tell you what this is by printing it, and then after that you can proceed with your code however you want. Out that println, and here we have what did I say? End of program. Okay, so let's say I do int a is equal to 3, b is equal to let's say 0. Okay, and I'm going to do int c is equal to a divided by b. This makes no sense because I cannot divide by 0. That's not a possible thing. So that's what this is going to handle. Okay, so here it just told me nicely that, hey, this is an arithmetic exception. You're doing a divide by 0, but it didn't end the program. Right, this time it actually properly finished it for me. So that's how you would handle different cases. So can I change these? Can I like just say that, okay, only if it is what was this, arithmetic exception? So only if it is arithmetic exception, I'm going to do system.out.println. Okay, so let's say let's write that same piece of code again. Int a is equal to new int, and 2, we already have an a g. I'm trying to access int k is equal to g of 10. What am I doing here? I have an array of size 2, and I'm giving the 10th value of this array to k. Okay, so if I run this, yeah, it's going to say divide by 0 exception. So it started over here. It just there was some problem here. So it just goes into this arithmetic exception. It told me what it is. And then it said end of program. Okay. Now, if I were to do these lines here, again, let's actually clear this code. Here all this. Okay, now let me run the same thing again. Now this time it again didn't go into this thing. It didn't go into this catch because here I'm just gonna handle the arithmetic exceptions. And even this end of program didn't happen. So this again threw another error for me. So if you want to handle different errors, then you can actually put different kinds of uh, exceptions. So here I can put multiple catch blocks. So if there's an arithmetic exception, do this. If it's an index out of bounds exception, do this, and so on. Okay, so that's how you would handle different exceptions differently. So this is a good practice because this is now telling me that, hey, you made a divide by zero, and if I was in this part of the code, then I'll say you you are accessing an unknown. Sorry about the typos. Unknown element. Okay. So this is what your code would ideally look like. Okay, so you are no sure that certain different exceptions will occur, and this is how you're going to handle them. So it's an arithmetic exception, you're going to say this. If it's an array index exception, you're going to say this. In real life, there's going to be something else. Let's say I am trying to log in into a page, and you enter your username, you enter your password. This code is checking. Okay, is this username there? Yes, it's there. Is this password there? Yes, it's there. Is the password correct? No. Okay, so then it can come into this exception, like password incorrect exception, and it'll tell you your password is incorrect. Or if your username doesn't exist, then it'll come here and say username doesn't exist exception. It'll say, hey, you don't have an account with us yet. Would you like to create one? Sign up. Okay, that kind of stuff. So these catch blocks, you can have multiple. You can handle different errors differently. And there are some things like this which you always want to execute irrespective of whether you want your program executes or not. So that is what you have finally for. Okay, so this is the normal way to write. You have try, catch, finally. So try is where all your code normally goes. Catch is where you're handling exceptions. Finally is where you want to do something irrespective of if it works successfully or not. Okay. So here if I write finally, now even if I get an exception in between, uh, like even if I don't have, let's say, okay, let's say some exception actually occurred and I don't have arithmetic exception. Let me do, what do I do? Okay, I'm going to remove this. Okay, so what is it doing? Only arithmetic exceptions are being handled. No other exception is being handled. So now if I hit play, yeah. Uh, so it did throw that exception. It said array index out of bounds, but it still executed that piece of code which was there. Okay. Now don't worry about why this happened before this. This is just how Java handles stuff later because your exceptions are different and they might take a little longer to get handled. But this finally is always, always, always going to get executed. Okay, irrespective of what you do. So I think that is pretty much more what we need to cover. Are arrays objects? Yes, they are objects. So that's why you create them in the exact same way you would create an object. So here we have scanner scan equal to new scanner. Just like that, you create arrays also like that. So int this equal to new this. Okay, yes, arrays are objects. Process.exist is there in Java? Yes, I think there is. And I think you mean to say it is system.exit? Yeah, system.exit 0. This is possible. This status, but you shouldn't be using these in general, I feel, right? So are there any other questions, guys? I think we have covered everything that is there for today. Let's see. We have Java scanner, exceptions, reasons for exceptions to cover. Yeah, exactly. So an error would crash when they encounter an error. Exceptions, on the other hand, in code can be handled by the programmer. Yeah. What is exception handling? We've done it. Benefits also we did. Try catch. So you have block of code to try, block to handle errors. And finally statement lets you execute code after try catch regardless of the result. So even if there's an error or not, it's going to execute that finally is that. Hmm. Conclusion. Okay, yeah. And you can obviously create your own exceptions that you want, right? Just like uh, how we created public class my program, we can create public class new exception and then give it our own exception and say when you want to throw it. Like you can define rules of when those exceptions have to be thrown. So these can be something like custom exceptions. Right? So of course I have to create this, but because it's if it's there, then this will work. And I guess any other doubts? I think we're done with the class. Vinay, yeah, like you can let me know what I need to do next. Um, but yeah, if there are any other doubts, guys, please post them right away, and I'll be happy to help. Vinay, are you there?
Yeah, yeah, Prashant. So
Yeah.
audible?
So sorry.
So I didn't catch you. What is it?
Yeah. So I think I'm done with this lecture because I've covered everything that's there from start to finish, and start
I
with
think we
next
need to
topic.
run something called Cout. Is everything covered? Can you proceed with another 30 minutes or so?
Uh, I was told it was just input, output, and exception, so
Oh,
I
okay,
have
okay.
this much. So yeah, since this was my first class, I just wanted to see how things would go, and I wanted to see like
Okay,
how.
if you are
The,
done, mostly I think, yeah, I think we can start with the assignment. Before that, usually we give 10 minutes break in
oh,
between.
okay. Oh, okay.
Yeah,
Okay.
you can feel free to drop off if you are done. I'm gonna take the session.
Oh, okay. Cool then. All right. Cool. I'll probably catch you later after the session. I have a few doubts for this as well. Okay. 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 Cool.
Oh, okay, guys. Let's start the assignment classes. We have two questions to be covered in this. It's very basic question. I think these questions you might have faced in your college days. Okay, so are you guys back? Can I get yes in that case? Few yes. Okay, let me share my screen. Okay, okay. Hope you are able to see my screen. So the practice question here is one is to find whether a given number is prime or not. So that is one question, and the other question is what was the other question? Let me open. Uh, yeah, write a pseudocode to find whether the given number is prime or not, and write a pseudocode to reverse a given number. Okay, it's a number they are giving, and we need to write a. Actually, they asked for pseudocode. I'll give you the proper code itself. It's anyway. I think it's a very simple program, so no problem there. So let us start with I've just taken a simple online compiler. It's a simple main function which we have taken. Let us start with the prime number first. So I'll just assume that there is a number called something which is going to take input, but here we'll just directly give a number. So we know 29 is a prime number. I'm just taking that example. Okay, and so let us have a flag. So based on this flag, we are going to determine whether a given number is prime or not. So for initially we'll see that if boolean flag, but default value that we are going to assign to this flag is false. Okay, and now let me write a for loop for int I equals 0. Sorry, it should not be 2. It should be 2 because 1 is not a prime number and 2 definitely it's not a prime number, so it starts with 2. Anything less than 2, it will not enter this for loop and it will just print false, because 1 and 2 and 0, these are all not prime numbers. Okay, so thus it starts from 2. That's why I'm taking I is equal to 2, I less than or equal to here num divided by 2. Okay, so that's the basic maths. So like so for the number which we have to divide by 2, and like the very first half we are actually checking. So in that case we get to know that if there is anything which is not divisible by 2, then we get to know that it's actually prime, and we just increment the I value on each iteration. And now we need to add that condition: if num mod of I, that is if it is divisible by itself, no, it should not be so prime number is that, right? It should be either only divisible by itself or 1. That's the rule base. So we are going to start with 2, and we are going to check keep incrementing the I, and we check if this mod is equal to 2, is equal to 0 anywhere. In case if it is 0, that means it is not a prime number. So that's the only condition that we are adding. So if num mod of I at any point of time from I equals to till where it goes, right? If it is not divisible by 0, then we declare that this is not a if it is if it is divisible by any other number, that means if it gives mod of I as 0, then we come to conclusion that this is not a prime number. So we make flag equals 1 in this case, true, sorry, it's a boolean, right? True. And we can just break it. So no need, if we know that, see for example, if you take 10 and directly if we start from 2, we know that 10 is divisible by 2, right? 10 mod of 2 is going to give us 0. Then again we don't have to go with 3, 4, 5. Again we don't have to check. We know that this is not a prime number. We can just break the loop. So that way it will be more efficient. What happens if we don't break? So it will still work, but you'll be proceeding with other loops. It's going to take more time to execute this program. So just apply break if you have the condition is satisfied already. So that way we have added the condition, if condition, and now based on that, once the for loop is done, we just check if flag is there. That means flag is there, that means this is not a prime number, right? So we can just print system.print ln. So here I'll just do num is not a prime number. Okay. Okay. Else, so what I do is a prime number. So have I? Okay, this should be fine. Let's see. Okay, there is a println typo. Println. Okay. Okay, again there is a typo. print. My bad. Println. Yeah. So here you can see 29 is a prime number. If I take 15 or any other, it should show 15 is not a prime number. Okay, so we were asked to write a pseudocode, but we have actually written a normal code. Okay, so you want me to zoom, is it? Okay, let me zoom in. Is it better now? I'll give you the code as well, just for your reference. I don't know if I can copy this big code. Just the printing part is not there, but yeah, I think the whole logic is there. Anyway, you can take that. If flag is there, it's not a prime number. If flag is false, it's a prime number. So line number 9, is it? Line number 9. So this is a simple for loop. Okay, so here what we are doing is um, we are taking from I equal to, because I, if we start from 0 or 1, 1 is not a prime number, we already know, and that's the reason we are starting from the value 2. That is why we have taken I is equal to. And why we have we have taken less than or equal to num. We can actually means less than num divided by 2. We can actually even do this, but the like math logic says that okay, if first half of the number, like if you divide by 2 and if there is no divisible in any value within the first half of the number, then it is actually a prime number. So we don't have to go till the number, actual number 29. So 29 divided by 2 is this is an integer value, right? It will take 14. If till 14, if there is no value which is with mod of that number is not equal to 0, then it is already considered as prime number. So we usually take num divided by 2. That means it will run till any given number. For example, here it was 29, right? It will run till 14, and I value keep on increasing to check if there is any divisible for 14. So in that case, yeah, so 29 is divided by 2 is actually 20, 14.5, but this is an integer, so it will just ignore that decimal values until till 14 it will run. Okay, cool. And now I plus plus is just we are incrementing the value of I, so that it just basically mm, gets us the divisor. So here we are checking the number mod of this high value. So high value keeps on increasing. It if it is divisible by num value is divisible by 2, or it is 3 or 4 5, up will go till 14. So till from 2 to 14 there is no number which is going to divide 29. So that way we come to know this is the prime number. Okay, any confusion or anything? Okay, it's clear, fine. Let us move on to the next question. I've already posted this. I'll move on to the next question. What is the next question? That is, I think we have to reverse a number. Okay, I'll take a number int num equals, I'll just take 1 2 3. This is a number, and so here we again have to, reversing a number means we have to start from the unit place. Okay, unit place, next tens place, hundred place. So how do we do that? So just we get the what do you mean, like if I divide by 10, what happens here? So um, first forget about divide by 10. Okay, if I divide by 10, 123 divided by 10 is, it's an integer, I'll just it will be 12. But how do we get the 3? All we have to do is this is for the remainder, but if we want to get the remainder, we have to do 123 mod of 10. So this is going to give us the remainder 3. So we are going to store 3 in the new number, and then again we have to divide by 10, so we get the next tens place. Again for this we do mod of 10, which we are going to get a remainder 2, which we are going to add it to our existing some variable. And then again we have to divide 12 by 10, which is going to give us 1. 1 mod of 10 is going to give us 1. We are going to add it to back to the number. So this is the actual logic to reverse a number. Now let us see the code for it. So I've just written how we do it. So we'll store it in a new variable called reverse. For now, initially it is 0. Now while num is greater than 0, as long as number is greater than 0, that is this one, because we keep on dividing by 10, obviously at one point it will be 0. So that's why we are checking if num is greater than 0. So here I'll take int reminder. Okay, equals reminder. How do we get? We just have to do number mod of 10. So that is going to give us the reminder. So what we do is, so to this reverse, right? Reverse equals, we are going to update the reverse. So if it is tens place, then we have to multiply this value by 10. So that is going to give us the actual value. So here it is 0. So since there is no number in the reverse, so all we have to do is 10 into, these are all basic mathematics. I'm not doing anything extra. It's just that we are converting that into program. So plus reminder. So this will make sure that, so base it will try to add in the same order, tens units place, tens place, and hundreds place, like that. So initially it will be a unit place, so 0 0 into 10 is 0, and we just add it to our unit place. And next time there will be some value that is 3 or something, and 3 into 10 is going to be some 30 plus so and so is going to add it to the tens place. So that is how the logic is working. Now we got the reminder, we added to the reverse value. Now we have to divide our num by 10, because we are done with 3. Now we have to deal with the next 12. So now num divided by 10, so which is going to give us the rest of the value. So similarly we do it for the for same approach for rest of the numbers. And finally if I try to print ln reverse, yeah, so we got the actual reverse number. If you give any big number, it should still reverse it. Yeah, so 14211, yeah. So I'll let me paste this code so that you can understand this logic. These are all pure mathematics. I think how we get the reminder, how do we get the divide, why we are dividing by 10 in order to get the next set of numbers, and why we have to do this. It's all pure mathematics. That is something that we have converted to a Java program. So I'll post this code in the chat window. Okay, great. So any doubt in this question? So we have covered both the practice questions for this session. So if there's any doubt or any question, let me know, or we are good to wind up this class. Any questions? Usually the class sessions usually go till 10 o'clock, but maybe it was a simple topic. That's why the instructor has completed a little faster. Yeah, I think, but usually it goes till 10. And after that, we start the assignment question. It goes till 10, 10:20 or 10:30 sometimes. So, but today it ended a little fast. Okay. So, cool. Then we'll meet up in the next classroom session. Okay. Thank you guys. Bye.